So I'm Noemie Globus, and so I'm studying a lot of things. I started by studying black holes and cosmic rays. So they are very energetic particles that are produced by havents around black holes. Supernovae, I don't know if you heard about explosion of stars. Yeah. And then I become interested to understand better the effect of radiation, so all this cosmic radiation, like light, very energetic light, or very energetic particles, when they are produced by these events around black hole or from dying of massive stars, they will travel in our galaxy, and they will interact in the upper atmosphere and produce a shower of secondary particles. And right now, while we are talking, you and I are irradiated all the time by cosmic rays.
Wow.
So I think that it's important to consider the effect of cosmic rays to understand better how life could have developed on, other planets, for example. So now I'm becoming more and more interested in astrobiology, and I'm studying this for I think the last 4 years. So and I'm going to talk about this here tomorrow.
Wow, that's cool.
Thanks.
Why haven't we found any aliens yet?
Why we haven't found aliens?
Yes.
Oh, that's a good question. I don't know. There are like two possibilities. The first one will be a bit sad, is that life is a very rare event. So, maybe in this part of the galaxy, it happens so rarely that we will not, be able to find something. Or it's because maybe, on Earth, we have this specific condition. We are protected, you see, by an atmosphere. So we can walk on the ground. We are protected from cosmic radiation, from radiation from the sun. But maybe another system, life is actually developing underground. So maybe there is a ton of life everywhere, but we are not able to detect it. So that's the two possibilities.
Do you think there are any aliens? And if so, what kind?
So, yeah, I think there are. I don't think we are alone. But what kind, I don't know, and I don't think anyone knows. As I said, maybe in the other system it's easier for life to have developed underground. For example, in our solar system, we have some moons around Jupiter, Jupiter, and Saturn. So there is a Europa, it's a moon of Jupiter, and Enceladus, it's a moon of Saturn. And these moons have oceans, but under the ice. So it's like an icy crust, and there is ocean underneath. And some people think maybe life could have developed there. So of course it will be difficult to detect from here, but we will be able to maybe send some, probes, space missions, to actually see if it's possible to detect some sign of life there. So you see, and if we find life in our solar system, that would be amazing, and then we could maybe understand better if we could have life underground or underwater in other systems. Or maybe one day we would be able to have some, signature of life from some atmosphere of a planet, or yeah.
How are you going to find out?
What I'm doing is I'm trying to understand what aspects of life are universal. I will try to be less technical. So, for example, if you take physics, physics.
Sí.
So if you study how light is propagating, or for example if I take an apple, how it will fall, about gravity, right? So these laws of physics are the same everywhere. So it's easy to do astrophysics, because if the laws of physics are the same everywhere, they are universal, then you can study a neutron star, a black hole, etc. But for life, we don't know how to define life, actually. So we don't have a good definition for life. So I am trying to better understand if we can define some universal aspects of life, because that would be important for astrobiology. So what we do is that we look at the properties of life on Earth, right? So we try to define biosignatures. So, for example, we know that life needs water on Earth. So what we do is that we define some kind of zones that we call habitable zones around planets when water can exist in a liquid form, and we look there. So that's one example. What I'm more interested in is it's a property of life, of a living organism like you and me, which is unique. It's called homochirality. So I'm going to talk about this tomorrow here. And basically in your DNA, you have molecules, right? You know what a molecule is?
No.
It's an ensemble of atoms that are bound together.
Mm-hmm.
And it can take a different, like a puzzle, spatial arrangement, right, in space. So you have atoms like a ball and sticks, and then you can imagine different configuration. And you know what is DNA?
Yes.
Okay, so it's a molecule, but there is the genetic information inside it, right? So this is unique to life, right?
Yeah.
And it's replicating also DNA. So that's also unique to life as we know it on Earth. So this molecule, in general, I mean, if you try to make it in lab, it can come into mirror image of one another. This is how, I mean, if you make drugs, for example, in laboratory, aspirin, you will always get 50% of left-handed and 50% of right-handed, like in equal amount. But in living system, like you and me, life choose to use only one-handedness, and we don't know why. And this is very, very unique and specific to living forms. So this is what I'm studying of the step, how life made it to this, what we call homochirality. So meaning how life made the step to be made, like the architecture of life is only made with one-handedness of the molecules. And I would say we should look for this outside to detect, you know, this type of signature. Like if we see only one type of handedness, maybe it's a sign that maybe there is life there.
That's cool. If we find them, should we try and meet them?
Yes. I mean, why not?
That's cool.
I know that in many movies, I mean, some
Yep.
some interaction are described scary, but yeah, I think we should meet them. What do you think?
Yeah, I think we should too.
I mean, that's the purpose of trying to find them, right? I mean, if we find them and then we say we don't meet them, I mean, what's the point? So, yeah.
Thank you for coming.
Okay, well, thank you for your questions. It was very nice to meet you.
Nice to meet you too.